This tutorial will demonstrate how to add a new task to an existing application. So if you look at the flight regulator application, what we would like to do is add a new task at the top of the existing tasks. So the existing tasks we have right now are outlet pressure test and outlet flow test. We want to do a leak test at the beginning. So what we're going to do is go into the tree view and open up our existing tasks, right click and click add, and add leak test. And there we have it. Now we have a leak test. Now I'll provide a little bit of detail about this leak test and why we want to add it. The leak test is a handy test to do for a pneumatic system before you perform any other tests. Just ensure that there's no leakage after you've installed a part. So in this application, we have added a flight regulator right here. It's flight. So it's not a breathing regulator, that's a flight regulator. And what we want to do is we want to pressurize the inlet side of it. So we want to pressurize this side of it and just ensure that the connection has no leakage. So this side of the pneumatic circuit is not relevant. We're not going to turn on the vacuum pump or anything else. So what we want to do is we want to turn on this switch right here and then supply 120 pounds of pressure to the inlet side. So we want to use PID 1_1 and we want to set that to 120 psig, the maximum range right here on for inlet pressure. And then just ensure that there's no leakage. We do that using leak tech solution, which creates bubbles if there's leakage. So a user will apply that to any external connectors and just double check to make sure that there's no leakage. In terms of the test sequence, we'll reuse a few of these steps. We still want to have them enter the username and enter the serial number. These are taken care of within the session information task, so we don't need to add these. Right now we will, however, need to instruct the end user to install the part. Turn on switch S1 and have PID 1_1, which is right here. Generate 120 psig. So switch 2 we don't need that PID. We don't need to record any of this stuff. What we do want to do after applying 120 psig is, for step 6, we want to have an instruction, apply leak tech solution. So we want to have an instruction for that, apply leak tech solution. And for number 7, we want to ensure that no leakage was observed. So we'll say was leakage observed. And if it was, then we're going to fail. If not, then it'll pass. So it's a very simple test. We can do it very, very quickly. you may notice that the PID, within the PID, there's no array, no looping that we need to go through for this test. So we're going to use we're not going to use a task array. We're not going to use a primary and secondary array. So in our previous examples, we used a primary array, this grouping right here, and then a secondary array, and then we added our result and parameter objects. So in this case, we don't need this because we're not going to loop through. Instead, we're going to go right from the task object, which would be leak test, and we're going to add a parameter and a result object right there, right from that instead. So we've added the leak test, and as you can see, by default, use array equals fault by default when you add a new task. So when that is set to false, then the parameter and the result appear right under the leak test, just as shown here. So you have leak test, and then the parameter and the result object will appear right under that. So the first step is to add an instruction, apply leak tech solution. And I'll just say, please please apply leak tech solution to the connector on the inlet pressure side of the regulator, and then click yes when completed. For now, we'll leave the HTML image out of there. The next step would be to supply a second instruction. Was a leakage observed? Was leakage observed within the inlet pressure connections? Click yes if leakage was observed. Click no if okay. So it'll fail if the user clicks yes, and no if he clicks false. Clicks no. So we can add the inlet pressure as a parameter. And also, was leakage observed as another parameter. And we'll set that to true or false. Well, we'll have a was leakage observed as a result object, actually. So that actually is going to be a result object, and this is going to be a parameter. So the inlet pressure is a parameter, was leakage observed is going to be the result object. So for the parameter, we're going to add inlet pressure and set that to 120 psig. And then in terms of the result, we're going to add was leakage observed. And for this, there's not going to be any units because it's true or false. So what we're going to do is right now we're going to turn S1 on, switch 1. Turn that on, and we're going to then enable PID 11. So we're going to open up the VSTA macro, go into the newly created module leak test, and go into the subroutine leak test. And right here, we're going to copy switch 1, copy the name of it, and paste that, dot value equals true. Next, we're going to open up the PID 11 and copy that name and paste it, dot point set, and then we want to make sure that we use the last voltage, so set that as true, and enable the PID. And we're going to set that equal to the parameter inlet pressure. So we'll copy that name, paste it here, dot value. The next step we want to do is we want to dwell. So we just go into PIDs and copy that name, or you could just type it. But the parent object of the PIDs has the operation